I'm going to talk about static methods in Python. A static method is a method that belongs to a class rather than any object from that class, any instance. Instance methods, we're already familiar with them. They are methods that belong to individual objects created from that class. They're best for operations on instances of that class, any objects. Whereas static methods, they're best for utility functions within a class that do not need access to class data. I'll demonstrate the differences between an instance method and a static method. We'll begin by creating a class of employee. We'll need a constructor. Let's define that. To create an employee object, we'll need a name and a job position. We will assign self.name equals name. Self.position equals position. We will create an instance method of getInfo. We will return employee info. We will return an f-string where we will display self.name equals self.position. Class. Well, then it would be a living duck. Hey, what's going on, everybody? Today I'm going to talk about static methods in Python. A static method is a method that belongs to a class rather than any object from that class, any instance. Instance methods we're already familiar with them. They are methods that belong to individual objects created from that class. They're best for operations on instances of that class, any objects. Whereas static methods, they're best for utility functions within a class that do not need access to class data. Methods that belong to individual objects created from that class that do not with them. Best for operations on instances of that class, any objects, whereas static methods, they're best for utility functions within a class that do not need access to class data. I'll demonstrate the differences between an instance method and a static method. We'll begin by creating a class of employee. We'll need a constructor. Let's define that. To create an employee object, we'll need a name and a job position. We will assign self.name equals name, self.position equals position. We will create an instance method of getInfo. We will return employee info. We will return an f-string where we will display self.name equals self.position. GetInfo is an instance method. Each object that we create from this class will have their own getInfo method to return the information on that object, the object's name and the object's position. Now we'll create a static method. To create a static method, we need a decorator of static method. Static methods are best for general utility functions within a class. We'll define a method to check to see if a job, a position, is valid, which we will name isValidPosition. So static methods, they don't have self as the first argument. We're not working with any objects created from this class. To check to see if a position is valid, we will pass in a job position, which I will name as position. I will create a list of valid positions. Let's assume that our company is the Krusty Krab. What are some valid positions? A manager is a valid position, a cashier, a cook, then let's say a janitor. Then we will return. We'll use a membership operator. Check if position that we receive is in our list of valid positions. What we have done is that we have created a static method. We don't need to rely on any objects to use this method. For example, to use a static method, we will use the name of the class, rather than any object that we create from this class, such as this. We don't need to do that. We type the class name, followed by the static method, isValidPosition. Then I did set this up to accept one argument. Let's check to see if a cook is a valid position. Then I do need to print this. What is the output? A cook is a valid position. What about a rocket scientist? That would probably be Sandy's job. That is false. A rocket scientist is not a valid position at the Krusty Krab. This is a static method. It belongs to the class, not any object created from that class. Now let's create a few employee objects. Let's say employee1 equals a new employee. We have to pass in a name and a job. Eugene will be the first name. That's Mr. Krabs. He will be a manager. Employee2 equals employee. Squidward will be a cashier. Employee3 equals employee. Employee3 will be SpongeBob. SpongeBob will be a cook. To call an instance method, we have to access one of the instances of the class in order to use it. If I want to check the info on employee1, I will access that object, that instance, use the getInfo method, then I need to print it. Take employee 1, get the info. Eugene is the manager. Let's do this with employee 2 and employee 3. Eugene, Mr. Krabs, is the manager. Squidward is the cashier. SpongeBob is the cook. For an instance method, you access an object, then call the instance method. With a static method, you only need to access that class. You don't even need to create any objects from that class. It's a general utility method. Alright everybody, those are static methods. They're a method that belongs to a class, rather than any objects created from that class. They're usually used with a static method. Call an instance method, we have to access one of the instances of the class. Manager, Squidward is the object, then call the instance method. Alright everybody, those are static methods.
Damn, bro. Oh, sorry, guys. Damn it. My brain is not running at this moment, actually, for real. So, if I get info here, sorry, not undo, and I just did like this. Just let's think about this like this and pass the parameter now. Bro, come on, man. Person.info, self.info. Bro, come on.
Get the info.
Oh, damn. Shit, bro. Yep. So, the John is 32 years old with employed with respect date. Let's replace with this. Yep, this is correct. So let's try it again. The John is 32 years old. 32. John is 32 years old who is employed with respect date. Okay, so person 2. The variant is 26 year old who is employed with respect. Sweet. Okay, cool. Not 2 3. The youngest 24 who is employed with respect date. Damn it, bro. So it's finally working. Now let's get this. Okay, cool. Person 1 into color, sorry, name. You're passing an argument, so you gotta print the statement. Come on, man. Person 1 name is Sean. Person 1 occupation is true. Person 3 occupation is false. Yep. And his respect is a W. And what about person 4? 3. L, bro. L for real. Damn, did I just write all this code in a day? Damn it, bro. I mean, this is so much for me, actually, for real. So I got this. So this is static method, which is only for the class. Am I right? This instance method only related to object of specific class. Is static method only related to class? Yes. And this is an instance method. Instance method, which is only for specific instance in the class. So this is about the static method and this. Now let's go further.
Oh, Eugene, static method. Today I gotta talk about that do not need access to class data. And well, everybody, those are static methods in Python. Hey, what's going on, people? So today I gotta talk about class methods in Python. A class method allows operations related to the class itself. They take CLS as the first parameter, whereas instance methods will take self. So, a class method allows operations related to the class itself. They take CLS as the first parameter, whereas instance methods will take self. Self refers to any object created from that class. CLS, meaning class, refers to the class, not any objects. Here's an example. We will create a class of student. We'll need a constructor to construct some student objects. All students will have a name and a GPA. Self.name equals name. Self.gpa equals GPA. We will also create a class variable for this demonstration of count. We will count how many students we create. Whenever we construct a student object, we will access the class of student, take our count variable, increment it by 1. Whenever we create a student object, increase count by 1. I will create an instance method of getInfo. Instance methods have self as the first parameter. We're referring to the object we're currently working with. I will return an f-string where we will display the student's name and their GPA. Self.name, self.gpa. I'll add a comment that this is an instance method. Now to create a class method, to work with class data, we will declare a class method with a class method decorator. Class method. What we're going to do is define a method to get the count, the class variable of count. This method will be called getCount. Rather than self as the first parameter, we'll be working with a class, CLS, meaning class. I will return an f-string, total number of students, add a placeholder, CLS count. Let's test this. To call a class method, you take the name of the class, followed by the class method, getCount. And then we do need to print this. What is the count of my current students? Total number of students is 0. Let's create a few student objects. We will create student1 equals, call the student constructor. We have to pass in a name and a GPA. Let's say that the name is SpongeBob. SpongeBob has a GPA of 3.2. We'll create 2 more students. Student2, student3. Student2 will be Patrick. Patrick has a 2.0. Then Sandy. Sandy's smart. In fact, she's a genius. She has a perfect 4.0. Now let's count the number of students. Total number of students is 3. When we call this class method, we can access or modify class data, this class variable of count. Rather than using self, we use CLS for the class. Let's create one more class method. This time I'll calculate the total GPA. Let's create one more class. Trick has a perfect 4.0. Now let's count the number of students. Total number we can access, or rather than using self, we use CLS for the class. Let's create one more class method. This time I'll calculate the total GPA of all my students. We'll need a class variable to hold that data. Let's say total GPA equals 0. Whenever we construct a student object, we will access our class of student, get the total GPA, then add plus equals this student's GPA that we have just created. Basically speaking, the total GPA, this variable, is going to accumulate all of the GPA of every student and store it as a sum. To find the average, we're going to divide it by the count, the number of students. We'll do that within a class method. To create a class method again, we need to use the class method decorator. I will define a method of getAverage GPA. The first parameter is CLS for class. I will check if CLS count, the count variable of my class, is equal to 0. That means if we have no students. If that's the case, if there's no students, we're going to return 0. Because otherwise we're going to divide by 0 and we'll get an error. Else we're going to return an F string. Follow this formula. We're going to take the total GPA of my class, class.totalGPA, divided by class.count, the number of students we have. That's how to calculate the average GPA. After getting the count of the number of students, to access a class method for the class. Let's create one more class method. Get. Speaking, the total GPA, this variable, is going to accumulate the average method. To create a class method again, we need to use the class method decorator. I will define a method of getAverage GPA. The first parameter is CLS for class. I will check if CLS count, the count variable of my class, is equal to 0. That means if we have no students. If that's the case, if there's no students, we're going to return 0. Because otherwise we're going to divide by 0 and we'll get an error. Else we're going to return an F string. Follow this formula. We're going to take the total GPA of my class, class.totalGPA, divided by class.count, the number of students we have. That's how to calculate the average GPA. After getting the count of the number of students, to access a class method, we take the name of the class, student, call the class method, getAverageGPA. Then I will print it. total number of students is 3. The average GPA is 3.06 repeating. After calculating the average, I'm going to add a format specifier of .2f.
Watching the video that you sent me, the one where you're showering with wet hair dripping. You know that I'm obsessed with your body, but it's the way you smile that does it for me. It's so sweet knowing that you love me, though we don't need to say to each other sweet. Knowing that I love you and running my fingers through your hair. It's so sweet watching the video where you're lying in your red lingerie 10 times nightly. You know I think your skin's the perfect color, but it's always your eyes that pull me under. It's so sweet knowing that you love me, though we don't need to say it to each other sweet. Knowing that I love you and running the fingers through your hair. It's so sweet. And I'll gladly break it. I'll gladly break my heart for you. And I'll gladly break it. I'll gladly break my heart for you. And I'll gladly break it. I'll gladly break my heart for you. And I'll gladly break it. I'll gladly break my heart for you. It's so sweet knowing that you love me, though we don't need to say it to each other sweet. Knowing that I love you and running my fingers through your hair. It's so sweet.
One, two. So you're on the prowl, wondering whether she left houses indoors, power for the cause, lights in the floors, and sweat on the walls, cages and poles. Call out the search for your soul, or put it on hold again. She's having a sly indoor smoke. She calls the folks who run this, her oldest friends, sipping and drinking, laughing at imaginary jokes. 'Cause all the signals are sent, arise, invite you to approach, and it seems as though those lumps in your throat that you just swallowed have got you going. Come on, come on, come on. Come on, come on, come on. Number one, party outflow. She's a certified mind blower, knowing full well that I don't.
That means if we have no students. If that's the case, CLS, return an F string. Take the name of the class, calculating the average, I'm going to add a format specifier of 0.2f, just around to 2 decimal places. And I'll add average GPA colon space, then we'll calculate the average. All right, everybody, those are class methods. Instance methods are best for operations on instances of the class, any objects. Static methods are best for general utility functions, which do not need access to class data. Class methods are best used when we're working with class-level data or we require access to the class itself, such as when we're working with class variables. Rather than using self as the first parameter, we're going to use CLS, meaning class. And well, everybody, those are class methods in Python. Yo, what's going on, people? So today I'm going to explain magic methods rather than using self as the first parameter, we're going to use CLS, meaning class. And well, everybody, those are class methods in Python. Yo, what's going on, people? So today I'm going to explain magic methods in Python. Magic methods are also known as dunder methods, meaning double underscore. You typically find these within classes. We're already familiar with one of them, our dunder init method. We have double underscores on the left and double underscores on the right. But there are others. I'll cover a few of the more beginner-friendly ones. So what these methods do is that they're automatically called by using some of Python's built-in operations, such as printing an object, seeing if two objects are equal, greater than or less than, instance, such as when we're going to use CLS class variables. Rather than using self as the first parameter,
says.
I just joked the band director. I got a brand new saxophone.
Violet, blue, green, red to keep me out.
We're going to use CLS, meaning class. Require access to the. And well, everybody, those are class methods in Python. Yo, what's going on, people? So today I'm going to explain magic methods in Python. Magic methods are also known as dunder methods, meaning double underscore. You typically find these within classes. We're already familiar with one of them, our dunder init method. We have double underscores on the left and double underscores on the right. But there are others. I'll cover a few of the more beginner-friendly ones. So what these methods do is that they're automatically called by using some of Python's built-in operations, such as printing an object, seeing if two objects are equal, greater than or less than. When we use many of Python's built-in operations with objects, we can define and customize the behavior of those objects. So in this demonstration, I'm going to create a class of book. We will construct some book objects. We will define a magic method, a dunder method, of init to initialize these objects. For a book, we need a title, an author, and the number of pages. We'll say num pages. Self.title equals title. When we create a book object. That's the title. Harry Potter. Then we have book 3. The lion. Here are my 3 book objects. When we call the class of book and pass in arguments, we will call the dunder init method. It's a magic method. It's automatically called behind the scenes. Within this magic method, we can define and customize the behavior of objects. And in this example, we're just assigning the attributes of title, author, and number of pages. That is one built-in operation of Python. What would happen if I was to print book 1 directly to the console? Here's what happens. Well, we're given a memory address. Here's book 2 and book 3. Well, we can customize this behavior. We will use the dunder string method. Double. Double underscore, str meaning string, double underscore again. We have one parameter of self. Instead of returning a memory address, we can customize this behavior. Let's instead return an f string. I'll add 2 placeholders. We will display self.title, the title of the book, by self.author. And I'll place the title within single quotes. Now let's print book 1. We have The Hobbit by J.R.R. Tolkien. Let's print book 2. Harry Potter and the Philosopher's Stone by J.K. Rowling, and Book 3, The Lion, the Witch, and the Wardrobe by C.S. Lewis. So that is dunder string. We can return a string representation of the object when we print it directly to the console. Here's another dunder method. We can check to see if two objects are equal. I will print is book 1 equal to book 2. That gives me false. If they were to have the same title, the same author, and the same number of pages, then Python would say they're not equal still. So let's customize this behavior. We will define a method of dunder equals, which is just EQ. For parameters, we have self, the first book we're examining, in this case book 1, and other. Other means the other book. We're examining two objects for equality. To do that, we'll see if the title of two books and the author is the same. We'll disregard the number of pages. You can have two different versions of the same book. They might have different font sizes, or the dimensions of the physical pages might be different. So we will return a Boolean value. We will examine if self, that's the first book, is the title attribute equal to our other book's title, and is the author of the first book, self.author, equal to our other book's author. If I were to run this, we get false. Book 1 does not equal book 2, but if they have the same title, I'm going to replace these, and the same author, then they would be equal, and we'll disregard the number of pages. Let's say that with this version of The Hobbit, they're using a smaller font size, so there's less pages. We're using dunder equals to compare if two objects are equal. What if I was to print book 2 is less than book 3? Like, what does that even mean? And I'm just going to get rid of these two lines. Type error, less than is not supported between instances of book and book. So we can't use less than on two objects. But we can customize that behavior by using dunder less than, which is just LT. We're examining one book and the other book. Self and other. Let's compare the number of pages. We'll compare if the pages of book 2 is less than book 3. We will return a Boolean value. Is self dot and other book and the other book. Self and other. Let's compare the number of pages. We'll compare if the pages of book 2 is less than book 3. We will return a Boolean value. Is self dot number of pages less than other dot number of pages. So now this should not give us an error. Dunder GT for greater than. For our first book of self, is it greater than the number of pages of the other book? Well, that's true. The number of pages of book 2 is greater than book 3. Let's use dunder add to add the pages of two books together. What would happen if I were to add two books together? Book 2 plus book 3. Well, we get a type error. Unsupported operand for book and book. Well, to customize the behavior, book 2 add the page is. Well, that's true. The number of pages of book 2 maybe we attribute plus 72. Heck, I'll even put this within an F string. Because why not? 395 pages within one of the attributes. Statement like this. Lion in book 3. Type error. Argument of type book is not iterable. We will define dunder contains. Besides self, we will pass in a keyword that we're searching for. I will return, then we'll use the in membership operator, is our keyword in self.title. I'm looking for the word lion. That's going to return true if lion is in the title of this book. Or is our keyword in self.author. Maybe we're searching for an author. Let's try that again. That returns true. Lion is in book 3. However, lion is not within book 1. That's false. Is rolling in book 2. That's the author. That is true. Is rolling in book 3. That is false. That is dunder contains. We are searching for a keyword in an object. Now we could search for a key given an object. For book 1, we'll use the index operator and look up an attribute. Let's get the title of book 1. The default behavior is that we get a type error. Book object is not subscriptable. So to customize this behavior, we will use dunder get item. Besides self, we have one parameter of key. We're accessing book attributes by indexing. With this object, return the value at this key. What's that attribute? We will check if our key that we receive is equal to title, which it is in this case. We will return self.title. What's the title of the book? So that would give me The Hobbit. Here's book 2 and book 3. What if the key is author? None. We didn't set that up yet. If key is equal to author, then return self.author. The author of book 3 is C.S. Lewis. 2 is J.K. Rowling. Book 1 is J.R.R. Tolkien. What about number of pages? Num pages. Well, we're not set up for that yet. I'm going to turn this into an else if statement. Page is 310. An F string. Key. Placeholder. I guess, unless it's... There is not. Magic method. Much better. Alright everybody, so those are magic methods, also known as dunder methods, meaning double underscore. They are automatically called by many of Python's built-in operations. They allow developers to define or customize the behavior of objects when we use those built-in operations. And well everybody, those are magic methods in Python. Hey everybody, so in today's video I got to talk about the property decorator in Python. The property decorator allows us to define a method as a property. We can access it like it's an attribute. One of the benefits is that when reading, writing, or deleting attributes, we can called by many of recognize the behavior of objects when we use those built-in operations. We'll disregard books. The Lion, the Witch, and the Wardrobe by C.S. Lewis. So that is dunder string. We can return a string representation of the object. 2. Return. Hey everybody, so in today's video I got to talk about the property decorator in Python. The property decorator allows us to define a method as a property. We can access it like it's an attribute. One of the benefits is that when reading, writing, or deleting attributes, we can add additional logic. The property decorator gives us a getter method to read, a setter method to write, and a deleter method to delete when working with attributes. In this example, we'll create a class of rectangle. We need a constructor. Let's define that. When constructing a rectangle object, we will need a width and a height. We will assign the attribute of width equal to the width that we receive when constructing this object. Self.height equals height. Let's construct a rectangle object. Rectangle equals rectangle. We need to pass in a width and a height. Then I will print my rectangle's width rectangle.width and the height rectangle.height. With my rectangle, the width is 3, the height is 4. Using the property decorator, when reading these attributes of width or height, I can write some additional logic. Let's say that when accessing the width or the height, I would like to display one digit after the decimal, then add centimeters. Here's one way in which I can do that. For each of these attributes, I'm going to create a method. We will define a method of width, no parameters besides self. For now, I'll write pass, and define height. Preceding each of these methods, I will use the property decorator. So at property. Now, when accessing the width or the height, will be returned with whatever's within these methods of width and height. But there's one change we're going to make to these attributes. We'll set these attributes to be private. Prefix each of these attributes with an underscore. This tells you and other developers that these attributes, they're meant to be protected. They're internal. We shouldn't access the width or the height directly outside of this class. Technically we could. I will access the internal version of width and height. We get 3 and 4, but we do have a warning. Access to a protected member width of a class. That applies to height as well. Our width and our height are only meant to be used inside of this class. If we need to get the width and the height, we will do so through these getter methods provided by the property decorator. So when accessing the width, let's return an f string. I will access self.private width, add a format specifier to display one digit after the decimal, 0.1f, followed by centimeters. We'll do this with the height as well. We will return self.privateHeight. So now when we access the width or the height, we will do so using these getter methods. If I access these private width and height attributes instead, again, they will be 3 and 4. It's kind of like they're raw. These attributes are meant to be used internally, inside of the class. So that's the point of a getter method. We can add additional logic when reading one of these attributes when we try to get them. We can also add setter methods if we would like to set or write these attributes. Here's how. Let's take our width. We will create a decorator of @width.setter. When attempting to set the width, we will do so using this method, .setter. When attempting to set the width, we will do so using this method. We will define our method name of width. We will have one parameter, a new width. We don't want the parameter name to be the same as the method name. That's why we're naming it something different. When setting the width, let's check to see if the new width is greater than 0. If so, we will take self.privateWidth equals our new width. Else, let's print something. Let's print width must be greater than 0. And let's do this with the height. Height.setter, define height. Pass in a new height. If our new height is greater than 0, assign self.privateHeight equals the new height. Else print height must be greater than 0. Before printing the width and the height, let's take our rectangle's width, set it to be 0, then see what happens. Well, we get that message. Width must be greater than 0. If I were to set width to be 5, well, that does work. Our width is now 5. Let's change the height. Rectangle.height. I will set this to be -1. Height must be greater than 0, and the height hasn't changed. What about 6? 6 does work. When using these setter methods, we can add additional logic when writing or changing one of these attributes. These are setter methods. Now, if you need to delete an attribute, here's how. There is a delete keyword. We will delete our rectangle's width and delete our rectangle's height. In this series, we really won't be using the delete keyword, but you should still know that it exists. So we will create a deleter method. Take one of the attributes, in this example width, we will create a deleter method. The method name will be width, the name of the attribute. there will be no parameters besides self. We will delete self.private width. Then let's print something just to confirm that this was deleted. Width has been deleted. Same thing applies to height. Take the attribute of height, define height, delete private height. Height has been deleted. When deleting our width or our height, we get that confirmation message, width has been deleted and height has been deleted. All right, everybody, so that is the property decorator. We can define a method as a property, meaning it can be accessed as if it was an attribute. One of the benefits is that we can add additional logic when we read, write, or delete attributes. The property decorator gives us a getter, setter, and deleter method. Getter methods to read, setter methods to write, and deleter methods to delete. And well, everybody, that is the property decorator in Python. What is going on, everybody? So So today I got to talk about decorators in Python. A decorator is a function that extends the behavior of another function without modifying that base function. We pass the base function as an argument to the decorator function. For example, let's say we have a base function of get ice cream, and you can pass in a flavor of ice cream. Well, some people might want sprinkles on their ice cream, and others may not. They might just want plain vanilla. Well, we could add sprinkles by using a decorator. We're extending the behavior of a function where we get ice cream, where we're adding sprinkles. But we may not want to change the base function because some people don't like sprinkles.